Assalamualaikum and good morning. Okay, let's proceed to 11.5, translation, reflection and rotation as an isometry. Okay, so what is congruence? Okay, congruent is when two images, they have the same size and same shape. Okay, for example, this is a triangle ABC and KLM. Okay, let's say ABC is the object and triangle KLM is the image. ABC and KLM are congruent because they have the same size and same image. So this is the object. Okay, so which one is the congruent image of the object? Is it A, B or C? Yes, it is C. Because you can see here, it asks for congruent image. When you have this word congruent, means that it must be the same size and shape. So C is the one with same size and shape as an object. Isometry is a transformation where the image is congruent with the object. We have transformation of translation, then also rotation and reflection. Okay, and this transformation, we will call it as isometry when the image is congruent to the object. Okay, so let's investigate whether translation, rotation and reflection, are they isometry transformation or not? Let's focus on object to image 1. So now we want to map the object to image 1. Okay, so image 2 and image 3, let's ignore it for a while. Okay, so if you look at this object and this image, okay, are they the same size and the same shape? Yes. Okay, it is the same size and the same shape. Means that this object it undergo isometry transformation. But what is the isometry transformation that it undergoes? Okay, so we want to determine that. Okay, so if we look at here, the object and the image, okay, let's name these vertices A, B, C. Okay, so from this image 1, okay, we name the image point. Okay, this is A, this is B, B prime, and this is C prime. Okay, okay, so and given to you the center of rotation, so this is rotation. You just take one point, connect it to the center of rotation, then we take the same the image of the point A prime. Okay, A prime, go to the center of rotation. Okay, then the degree of rotation is 90. Okay, object is mapped to image 1 under a rotation of 90 degree. Okay, 90 degree in a clockwise or anti-clockwise? This one. Clockwise, okay? In a clockwise rotation. Okay, at center of rotation. Okay, so the size and shape are the same. Okay, same. So rotation is isometry transformation. Object is mapped to image 2. Okay, so this is object and this is image 2. Alright, so let's again name the point. This is ABC, and for image 2, okay, where is this will be the B prime. Okay, this will be A prime and this will be C prime. Okay, every point have the same distance between the image and the object. Okay, means that object is mapped under reflection. Where is the axis of reflection? Already given to you here. Okay, on the axis of rotation. And can you please look at the object and image? Does they have the same size? What about the size? Object and image, they are the same. And what about the shape? Yes, they are the same. So means that this reflection, this transformation is isometry. Object is mapped to image 3. Alright, so this is the object and this is image 3. Okay, as usual, we name the point. Okay, this is A prime, B prime, and C prime. Okay, so if you look at here, okay, what is happening? Okay, I think this is this object is mapped to image 3 by translation. How does it A is mapped to A prime? Okay, so first of all, it moved to the right. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so on x-axis, it will move 8. And it will go down 1, 2. Okay, when it goes down, okay, it will bring to -2. Okay, let's check. Is this true? Okay, do we have the same? Can we get C prime by using this translation on point C? Okay, let's test. 1, 2, 3, 4, 5, 6, 7, 8. Then it goes down by 2, 1, 2. Yes, we will get C prime. So it is confirmed that object is mapped to image 3 by translation. Okay, by translation 8, -2. Okay, so again, we want to determine, is it isometry transformation? Okay, so we look at the shape of object and image. Is it the same? Yes. Okay, what about the size? Is it the same? Yes. So it is confirmed that this transformation is isometry. Okay? Okay, so in conclusion, under translation, reflection and rotation, the size and shape between object and image are the same. So, object and image under this transformation are congruent. Hence, translation, reflection and rotation are isometry transformation. Okay, so in other words, we can say that isometry transformation is a transformation that will produce image of the same shape and size as object. Okay, so let's do this few questions. Okay, number 1, determine whether the following transformation is isometry or not. Okay, so you look at here. Okay, is this 2 is isometry or not? Okay, so let's do point A, B, C, D, A, B, C, D, A prime, B prime, C prime, D prime. Okay, so AB, okay, it looks different from A prime to B prime. Means that the size is already changed. So this is not isometry. Okay, let's look at B. Okay, is this the same shape? No. Okay, it's different here. So this is also not isometry. Okay, for C, this is the object and this is the image. Okay, so you must name all the vertices A, B, C. So this is A prime, B prime, and C prime. Okay, so to make sure is it the same size or not, you need to calculate the length here. How many boxes here? Okay, so this is 1, 2, 3, 4, 5, 6. 6. So from A prime to 6 prime, it should have 6 also. 1, 2, 3, 4, 5, 6. Okay, this side is congruent. Okay, what about this side? Okay, so this side it contains, it's actually the diagonal of these 3 boxes. Okay, so kalau kita tengok kat sini, yes, this is also congruent. Okay, and BC, is it congruent? Okay, we don't need to check because if AC is A prime and C prime is congruent, and also A prime and B prime is congruent to the object, means that B prime and C prime also congruent to BC. Okay, so this is isometry transformation. Alright, so D. Okay, let's look at D. This is the object, this is the image. Alright, so let's name the vertices one by one. Okay, let's start from here. This is A, B, C, D, E, F, G, H. Okay, so from here, okay, let's look at the images. Okay, this is A prime, B prime, C prime, okay, D prime, E prime, then F prime, okay, G prime, H prime. Okay, so what you need to do? Okay, you need to make sure is the size is the same or not, and also the shape. Okay, the shape it look like the same, but what about the size? Okay, jom kita tengok size dia by calculating the boxes for each length, each size. Okay, AB. Okay, you see here it's the diagonal of 2 boxes. Okay, so yes, so these sides are congruent, A to B. Okay, B to C, is it congruent? B to C consists of 2 boxes. Same goes to B prime to C prime. So this is also congruent. Okay, now C to D. Okay, C to D, okay, it consists of 2 boxes and the diagonal. Okay, so C to D, this is C, this is D. We have 2 boxes and the diagonal. Yes, this is also congruent. Okay, now D to E. Okay, it consists of the diagonal of 1 box. Same goes here. So it is also congruent. Okay, E to F, the diagonal of 1 box. Okay, this is also the diagonal of 1 box from E prime to F prime. So it's congruent. Okay, F to G, 1 boxes. Same goes here. So congruent. G to H. G to H is diagonal of 1 boxes. So same goes to here. And A to H, diagonal of 2 boxes. Yes, so all sides are congruent, means that this shape, these 2 object and image, they have the same size and the same shape. So they are isometry. Okay. Okay, number 2, determine whether each of the following transformation is an isometry. Okay, number 1, a reflection followed by another reflection. Okay, means that they have 2 reflection. Is it isometry transformation? Yes, no problem, because reflection itself, it is an isometry transformation. If you have 3, more than 2, more than 1 reflection, it will not change the shape and size of the image from the object. Okay, a translation, yes, it is isometry transformation. And C, a repeated rotation, means that we rotate it many times, several times. So this is also isometry transformation. Okay, because it does not change the size and the shape of the image from the object. Okay, now we go to 11.5.3, solving problems. Okay, before we go to the question, okay, how to name a congruent polygon? Okay, so let's say you have A, B, C, D. So, the congruent polygon, you must name the image, okay, by the same sequence as the object. Okay, so this is A prime. Where is A prime actually? A prime is here, right? A prime. Okay, then this is B prime. Okay, then this is C prime and D prime. But they name the image by another name. So it's okay, but you need to name this polygon by using the same order. Okay, means that it must start from S, because S is the A prime. So S, R, Q, P. Okay, so this is how you name a congruent polygon. Okay, in the diagram, A, B, C, D is the image for P, Q, C, S under an isometry. Given DCS, okay, DCS is a straight line. Determine PQC. So we want to determine this angle. What is this? Okay, this is angle PQC. Okay, how do you solve this? Okay, first of all, these two are congruent image. Okay, so means that this angle, it will have the same angle as this. Angle DCB will equal to SCQ. So let's say this is X, this will be also X. And this is a straight line. So the summation of angle on a straight line is 180. So X plus 50 degree will equal to 180 degree. So now we have 2x equal to 180 degree minus 50 degree. So x is equal to 130 divided by 2 is 65 degrees. Okay, so this is 65 degree. So how do we find CQ? Okay, so can you see this is an alternate angle. This one, this PQS will be equal to this angle because they are alternate angle. Remember, form 1, alternate angle. This angle will be equal to this angle if this is parallel line. Okay, this is parallel to each other. Alright, so PQC is equal to x plus 50, and x is 65 plus 50. Then we will have the answer 115. Okay, this do self-practice 11.5, page 233, question number 3, 4, 5. Okay, that's all for today. Thank you.